Chapter 2, Number 56. You are driving through town at 16 meters per second when suddenly a car backs out of a driveway in front of you. You apply the brakes and begin decelerating at 3.2 meters per second squared. How much time does it take to stop? And then after braking half the time found in Part A, is your speed 8 meters per second, greater than 8 meters per second, or less? And then finally, find the speed to confirm your answer. So we draw our picture, and really, despite all the drama in the picture or in the problem, there's really not that much to draw. The car at time t equals 0, the car is x equals 0, has some initial velocity v0, which is given as 16 meters per second. And then you, at some later time, which they tell us, which we're looking for, so I'll call this time equals tf, which I don't know, and a position, which I don't know. The velocity is 0, and during that entire thing, the car is decelerating, which means it's accelerating against its velocity, so it's accelerating that way. And we're going to put it in as minus 3.2 meters per second square. All right, and so we look here and we say we want to know how much time does it take to stop. So we have velocities and accelerations, and we want times. We don't know the distance, we don't care about the distance, so I'm going to try to avoid using the distance. And instead I'm going to remember that the velocity at any time is the velocity at the start plus the acceleration times the time. So that when it stops, our velocity is 0. Our initial velocity was v0. Our acceleration is whatever, and the time is tf. So I can solve this equation for tf. I can do that by subtracting v0 from both sides, getting atf equals minus v0, and then dividing by a on both sides, and I get tf is minus v0 over a, which is minus 16 meters per second, divided by minus 3.2 meters per second square. Happily, we see that the two minuses cancel out, and we get plus, and our number is 5. That's kind of convenient. 5 seconds. So our final time here turns out to be 5 seconds. We can reason for part B. After braking half the time, is your speed 8 meters per second or greater or less than that? The key is to remember that the velocity here is proportional to the acceleration, and for constant acceleration, the amount of velocity lost in a fixed amount of time is the same. So if we're talking about the first 2.5 seconds or the second 2.5 seconds, we know that we will lose the same amount of velocity in that time, which means we need to lose half of it in half the time. It's going to be proportional to the amount of time we have. The amount lost is proportional to the amount of time we have. We should, however, go on and show that. But showing it straight up is actually not that hard, because we can use the same v is v0 plus at, because that's true at any time, not necessarily starting at any time, but really at any time that we have. So we again have, we're going to put in the 16 meters per second for v0, and we're going to take our acceleration of minus 3.2 meters per second square, we're going to multiply it by half of the 5 seconds, which is 2.5 seconds. And so v is going to come out to be 16 meters per second minus 8 meters per second, which of course ends up with 8 meters per second. So the subtle bit here is that we lose half of that in half the time. All right, the amount we lost is 1/2 of this. If we've lost a half, we're left with a half, so we still end up at 8.